Welcome back, Ms. Awinup. I hope you didn't forget me. I'm your grade 10 maths teacher. Okay. Now, in our last lesson, we looked at Pythagoras and applications of Pythagoras. Okay. That was our last lesson under Pythagoras. This week, we are going to look at trigonometry. Okay. Trigonometry. Now, let's have a look at what trigonometry means. Now, this is another word that is derived from the Greek language, okay? Now, trigonometry, simply 3 Greek words put together. So the first Greek word is tri, which means 3, all right? Gonia, which is this part of the word here, which means angles, okay? And metria, which means measuring or measurement, okay? So trigonometry simply means that it is the study of the angles, measuring the angles and their relationship to the sides of the triangle, okay? So let's look at the triangle. By now we should already have an idea. We looked at the right angle triangle when we were learning about Pythagoras. Okay, so we're still looking at the right angle triangle in trigonometry. Okay, so let's have a look at this. Okay, so this is a right angle triangle. Remember that this little box in the corner indicates that this is a 90-degree angle. All right, a 90-degree angle. So we are going to look at how trigonometry applies in the right angle triangle, okay? The first thing we need to do is identify the sides in this triangle. Now, how do we identify the sides? Through the location of the other angles in the triangle, okay? So for this case here, let's say that we have a triangle with this symbol here. Now, what is this symbol? Okay, it is called theta, okay, theta. Now, theta is used to represent a given angle when there is no value, okay? So in this triangle, we have theta, all right, 90 degrees, and we have this other angle here. We are not going to look at that in this lesson yet. Let's have a look at theta, all right? We are worried about theta. Now, there are 3 main ratios in trigonometry. Those ratios are the sine ratio, the cosine ratio, and the tangent ratio. Now, what do you understand about ratios? You already know from grade 8 and grade 9 that a ratio is the relationship between 2 quantities, okay? The relationship between 2 quantities. So, with that at the back of your mind, let's look at why they are called trig ratios, because it is the relationship between 2 sides, okay? 2 sides in a right angle triangle, okay? So the first ratio we look at is the sine ratio, okay? Sine ratio. Now, we'll go back to our triangle here. Remember, the ratios are used in terms of a given angle. So here we have theta. So let's say sine theta, okay? Sine theta is the relationship between two sides. The sides that are important in the sine ratio is the opposite and the hypotenuse. Now, what are these two sides? We have to go back and see where those sides are. Okay, so in terms of theta, let's identify our two other sides here. Okay, now the side that is opposite theta, all right, the side opposite theta is known as the opposite side, but always abbreviated to OPP. Okay, the side which is here, let's use arrows. Okay, this side is next to theta, so we say it is the adjacent side. Again, we are using the abbreviations here. OPP for opposite side, ADJ for adjacent side. Now, remember from Pythagoras, the longest side in a right angle triangle, always opposite the right angle, is known as the hypotenuse. Okay, and that hypotenuse is abbreviated to OPP. All right, now we know the names of the sides. We go back to the ratio. So sine theta, remember, it is the relationship between the sides opposite and hypotenuse. So sine theta is equal to opposite over hypotenuse. Okay, then we have the next ratio. Again, we'll use theta. Cos theta is equal to the two sides here are adjacent and hypotenuse. So cos theta is equal to adjacent over hypotenuse. Now, the tangent ratio, all right, is abbreviated to tan. Okay, so tan theta, we do not need the hypotenuse when we are using the tangent ratio. So the two sides that we use here are the opposite and the adjacent. So the ratio is opposite over adjacent. Okay. Now, this is very important. You will need to remember this. If you still don't understand, always go back to your triangle and look at the sides opposite the given angle, adjacent to the given angle. Sine, opposite over hypotenuse, cos, adjacent over hypotenuse, and tan, opposite over hypotenuse. Now, one thing you must remember is that opposite and adjacent depend on the location of your angle, okay? So let's see. If I move theta, all right? This time, theta is up here, okay? Theta is up here. According to this triangle, if theta is here, opposite is here, all right? But for this triangle, this side is not opposite anymore because theta is now in this corner. So the side opposite theta is now this one, opposite, okay? The side next to theta is now this one. And of course, the hypotenuse does not move. It's always the long side. Okay? So now you can see adjacent and opposite depend on where the angle is. All right? Right. Now we've looked at naming the sides. Another method of naming the side is using the angles that are given. Okay? So let's have a look at another triangle. This triangle is special because it has a name, all right? And we name the triangle according to the angles in the triangle, all right? So this triangle is named A, B, and C. Triangle ABC, okay? Now, how do we identify adjacent and opposite? Very, very similar to what we've seen already, okay? But first, you must remember that when a triangle is named like this, the side is also given a letter to represent it, okay? So if this is angle A, this one here, then the side opposite to A is side A. Notice it is a small letter A, okay? Angle B here, which is the right angle, all right? The side which is opposite to B is now small letter b, okay? And angle C here, the side opposite angle C is small letter c, okay? So in this case, where the triangle is already named, we do not use theta. We use the angle that is already given here, okay? So if I were to find sine of this angle, it would be sine A equal to, opposite is here, A over hypotenuse is B, okay? If I were to find the cosine ratio, cos A, go back to your diagram, angle A is here, the side adjacent to A is C. So it's going to be C over B, okay? And tan A is equal to, opposite to angle A is small letter a. So A over adjacent to angle A is C. Okay, now we must understand how the triangle is named so that when you get to practical applications, you are able to draw your triangle, identify the sides correctly, and then solve for the answer. Okay, so this is important. You must understand this before we start working out the answers. Okay, now the next thing we are going to talk about, you would have something very important that we need to use when we are working with trigonometry. In grade 10, you would probably have seen these textbooks. Now, in these textbooks, we have what is called the trigonometric tables. Okay, the tables are located at the back of the textbook. Okay, at the back of the textbook. And in those tables, they give us the sine, cosine, and tangent values of angles 1 up to 90. Okay, so let's say I'll draw a very rough diagram here. You should be able to see this already. Now you will have angles 1 up to 90 and 3 columns that have sine, cos, and tan. Okay, so what's going to happen here? When you are using the ratios, you are given an angle. These tables must be used because we don't use calculators in grade 10. Okay, so these tables are very important. If you are given a value of an angle and asked to use the sine ratio, we need to go to the sine column, find the angle in the first column, and you will be given the sine values here. Okay, now we are going to learn how to do this, so don't worry. In our next segment, we are going to go through the examples and how to use the trigonometric tables to help us solve for unknown values of the sides in a triangle. Okay, I hope you have learned something new in our lesson today. I'll see you in our next segment.